Lesson 3.1, Reflections. This lesson starts out with a visual, and it has you look at each of these little tiles. It says the illustration shows irregular pentagon-shaped tiles covering the floor. So some of them are in blue and some of them are in white, and it has numbers 1 and 2. It says which tiles are copies of tile 1. So look at those closely, put your answer here, and then make sure it says if you were to move tile 1 from the design, like remove it or move it, what action would you have to do so it completely covers tile 2? So if you moved it out and rearranged it somehow, how would you cover up tile 2? Identifying rigid motion. Rigid motion is just that. It is a rigid motion. Rigid means stiff. So if you were looking at me and I did this, that's not a stiff movement. But if I did this, that's a stiff movement, opposed to totally not a stiff movement. My whole demeanor, my face, everything changes. So a rigid motion is rigid, just changes locations, opposed to a non-rigid where the shape actually changes or the object changes. So a rigid motion is a transformation that preserves, doesn't change, or keeps. It keeps the length and angles. So the angles don't change, the sizes don't change, it's just the location changes. It is a transformation. Is the transformation a rigid motion? So look at the pre-image. That's before anything happens. And then the image. Do these look like they just changed location? Or do they look like they changed shape? Keep in mind, rigid doesn't change the shape at all. It doesn't change the angles. It doesn't do any of that. It preserves the sides and it preserves the angles. So hopefully you can answer whether this is or is not a rigid motion. Try it. It says, is the transformation a rigid motion? Explain. So what you can do is sometimes you can't always tell. So grab a sticky note or a piece of paper. You can actually trace it on there, pick it up, rotate it, reflect it, any kind of movement, but it doesn't change the original shape or the pre-image. Here's another one. Is this transformation rigid? You might be able to tell, you might not, but does this shape, the pre-image, stay the same? Are the side lengths preserved? Are the angles preserved and just moved? Or is it changed in any way, like the size increased or decreased in size? That's called a dilation. Whether does it increase or decrease in size? That's called a dilation. Okay, reflection. That is basically what today's lesson is. Besides the fact that you're learning what rigid motion is, the thing that we're focusing on the most is reflecting. So a lot of you know when you look in the mirror, there's your reflection, but you might not know the math behind it. So a reflection is a transformation, a rigid transformation, that reflects each point of the pre-image. Now I know triangle ABC is the pre-image because right here, A, that little tick mark right there or apostrophe, that means prime. So A prime, B prime, C prime is the image. So pre-image is the original, image is the one after. So it says a reflection has 3 properties. If point A is on a line M, then a point and its image are at the same point. So basically, if there's a point on the line, when you reflect, it's going to stay on that line. It doesn't move, it doesn't change, it just stays on that line. So point A stays, and A prime is the exact same point because it is on the line of reflection. But if you have point B, see how B prime is not on the same point? It actually moved, it reflected across from point B to B prime. This segment is bisected at a perpendicular angle or 90-degree angle. So line M is the perpendicular bisector of B to B prime. So B to the line of reflection to B prime, those are exactly the same length. That's the bisected part. And then the perpendicular means that angle is 90 degrees. So C to C prime is also bisected through this line of reflection. See how there's 2 tick marks? And at a 90 degree. So the reflection of the triangle across line M is written like this. This is the notation. Reflection across line M of triangle ABC equals triangle A prime B prime C prime. Sometimes you just say triangle ABC prime, and that would be okay. Be really careful about this because sometimes the pre-image and the image are hard to tell. So really look for those tick marks, those primes. So we're going to look at this and actually see how to do this. And I love these steps because it tells you what to do step by step, and then you're going to have to do it. So how can you reflect this triangle across line L? So we're going to walk through this each time, and I'm going to hope this helps. So step one, first, you need to make a perpendicular line from each of those points. So from point F straight out, perpendicular with the line of reflection. It has to be perpendicular. So with that line of reflection, each of these segments or lines has to be meeting at a 90-degree angle with the original line of reflection. Okay, that's your first step. Then you're going to take each of these points, F, see this measurement from F to that point P, has to be the same distance to F prime to that point P. And I'm going to teach you how to use a compass. So you'll have a point and a circle will grow. Well, the radius of each circle is the same on both sides. Everywhere the radius is the same. So if I put my center point of a circle at point P and then grew a circle till it reached point F, that means the radius would go from P to F. And the other side of the circle, still the radius, would go from P to F prime. And that's what's going to help you find that other point. So again, equidistant, H to R, R to H prime, G to Q, Q to G prime. Each of those has to be equidistant or the same distance. Step 3, then you just connect. Connect all 3 of the points, F, H, and G prime. And then that will give you the image. So let's try it. I'm going to move this. It is easier to do this if you enlarge the shape first. So I'm going to enlarge the figure, and here it is. I need to reflect triangle LMN across this line N. So if you remember, or if you don't remember, go back. But I remember it says start with a perpendicular line. So more tools, perpendicular line. And it gives you instruction. It says choose a line to set. So I want it perpendicular to that line. And then it says choose a point. So I'm going to go, I want perpendicular to this blue line going through point M. See, now I've set it. So now it's good. So choose a line and then choose a point. So I'm going to choose another line. Has to be perpendicular with the blue line. Point L. And I need one more at point N. There it is. So I've completed step 1 on the previous slide. Step 1 was making perpendicular lines from each of those points. So I've got those. Now I need to create equidistant from this point right here to M, this point right here to M prime, but I don't know what that distance is. So I'm actually going to make segments at each of those spots. So I'm going to go here, segment. And if there is an easier way to do this, you go right ahead if you find a better way. So I'm going to make a segment from this line to M, from that line of reflection to L, line of reflection to N. And so that is actually putting segments in there so I can see the measurement. And then I'm going to take my compass. And this is what I was talking about on the last slide that I showed you, is that we're going to take a compass, a thing that makes circles, and I'm going to choose a segment, the radius. I want the radius this big. And then you have to choose the point where you want the center. There's my center. So now from M to the center point is equidistant from the center point to this point right there. Hopefully you know what that point should be called. If not, it's M prime. Okay, I'm going to do the next thing. Still on the circle, I'm going to click the radius length, and I'm going to put the center right there. See how it goes through L? Follow this perpendicular line. This would be L prime. I'm going to do it one more time for this segment with N in it. Move the circle, center, and there it is. Now this is really messy. If we were doing this in person and you were actually using a compass, it is this messy. To make it a little bit easier, you can color code these, and color coding, you click on what you want, and if you can hold the shift key down, then you can highlight multiple things at the same time. And if I want to color those something different, so I'm going to click on this circle, hold the shift key, this, and this, and I can make all the circles like gray, for example, or maybe this ugly orange color. So I'm going to make those all so they hopefully kind of blend into the background. Now, I need specific points. I'm going to go to the point, and from this center of the circle to M needs to be the same distance from the center to this, which is M prime. That is the whole point of using a compass. Because of the circles, the radius is the same on both sides. So go to point L, follow the perpendicular line to the line of reflection, follow it all the way to the other side of the circle. That's your L prime. N, follow the line, the perpendicular line, and be careful because that's not it. It's this. And you can always follow the circles to go around to make sure, okay, yes, that is the circle that went around on N. Another way to do that would be to color code all, here I have to go back to the arrow, color code everything that has to do with point M. So for example, I'm going to color code everything over here. I'm going to make that purple. So N type of things are all in one color. Or you could do that the same way. You could say all the M is in a different color. So then you know, okay, the M, everything dealing with the point M is in green or purple or whatever. That might help. Now, once you have all this done, you need to connect these points. Point M, L, and N, but you need the prime. So I'm going to make a segment, and I'm going to go from point M prime to L prime. And then I'm going to go from L prime to M prime. And notice I'm clicking. Then I'm going to click again in N. Then I'm going to go back to M. So all of this has created a reflection of the original triangle. What's cool is you can go back to the arrow or the selection tool, and I can click on everything I don't want to see. We'll try there and see if I got everything. If not, it's okay. So I'm going to say hide. Oh, I actually got a lot. So I could get rid of these lines as well. But as you can see, the distance from M to the line of reflection is the same from the line of reflection to M prime. Okay, reflecting with coordinates. This one you may have done in Algebra 1. You might have been good, bad. You might have not had enough practice. So we're going to get you a little bit more practice. So there's some good common errors to look up on these. So you might want to look at that. So you're going to graph. So I'm going to show you the solution, walk you through it. So here's a graph. You need to first draw the points. So graph the original. There it is. And it gives you some hints down here. And it says you're going to reflect it across the x-axis. So reflect, and the line of reflection is the x-axis. So that means the x-axis is the mirror. So you're going to have this shape over here, and it's going to go down here. Okay. So first you're going to draw F prime. So look at where point F is. It's at 0, 3. Notice that x-axis straight up and down, like vertically, those are perpendicular, which is nice. It's because the reflection has to be on a perpendicular line on the other side of the line of reflection. So to do that, instead of going straight up 3, you'll go straight down 3 from the x-axis. For point G, instead of going up 4, you should go down 4 from that x-axis. Okay? And you continue. So H is up 2, you're going to go down 2. And J, look where J is. J is on the line of reflection. And just a second ago, I told you if it's on the line of reflection, if it's right there on the line, that point doesn't move. So point J is not going to move. It says if you reflect X to Y, or the point XY, then you actually end up with the new point X negative Y. So look at 0, 3, 0, negative 3, 2, 4, 2, negative 4, and so on. So the original XY turns into X negative Y. Now we're going to reflect across the Y axis. Not the same, but it still is reflecting across an axis, but this one is vertical. So first thing, graph the points. The original figure, here it is. So you're going to use this Y axis as the line of reflection. So you have this figure that's kind of like partly over the axis, and you're going to reflect it. And so it's still going to be partly over the axis. But this time, starts with F. It's on the actual line of reflection, so it stays there. Point G prime, it's going to go right 2. So the reflected version would go left 2 from that y-axis. And that's true for all of them. So for point H, it's right 4. So you would have to go left 4. And there it is. And it keeps going through each of the points. And then J, notice J is on the other side. It started on the left. Well, if it started on the left, you just reflect it to the right. So it went -2 direction. So then you're going to go +2 direction, the opposite. And here is the conclusion. And you might already see the conclusion or the pattern. The conclusion says, if you're going to reflect across the y-axis, the x is what changes. The y stays the same, but the x becomes negative. So if it's a 2, it goes to -2. If it's a 4, it goes to -4. If it's a -2, the opposite of -2 is a positive. So if it starts positive, it goes negative. If it's negative, it goes positive. Okay? And again, look at those common errors. Here are some problems where you don't get a graph. If you want to graph them, that's okay. But refer back to those rules we just went over in each of these little dots. What happens, or what's the rule, if it's going to reflect over the x-axis? Hopefully you remember those rules, otherwise you can look back. What would the rule be if it reflected over the y-axis? And all you need to do is write the new coordinates. So if you remember the rule, go ahead and figure out what it should be. Are you changing x? Are you changing y? How are you changing them? Or you could graph them and then double check your work. Okay, reflecting points across the x and y. Here's the point. It is telling you the rules. If you reflect across the x-axis, y changes, becomes negative. If you reflect across, I said x-axis. If you reflect across the y-axis, the x changes or becomes negative. So you can start this. Here's point P. We'll put it right there. If this point is 5, 5, and I want to reflect across the x-axis, it's still 5, but it's -5. And this way, it's -5 for the x, but the y does not change. So you can mess around with that if you want to do different numbers so you can see them a little bit better. Here, maybe get rid of some decimals. It's a little bit cleaner decimals. So 2, 2.5, 2.5. The x's don't change, but the y's change. Here, the y's don't change when you're reflecting across the y value, but the x's change. You can play with that a little bit more to get some examples. Okay, we're going to describe. So what is the rule that maps? Basically, it's saying this is not a perfect XY coordinate. It is giving you a reflection. So you have a pre-image, you have an image. See all these primes? That's the image. You're given the coordinates. You have to figure out where the line of reflection is. Now, before you even start that, I would literally stick my hand or my pencil or something right here and say, okay, I think it's going right here. The line of reflection has to be somewhere in there. Okay, so that's what you're going to do. To do that, you need to find the point that is exactly between each of these corresponding points. So L and L prime, there has to be a point here in the middle because remember, they're equidistant. Between K and K prime, there has to be a point in the middle, exactly in the middle. And same with M and M prime. We have actually learned how to do that point. It's called the midpoint. So here's step 2. You're going to actually calculate the midpoints. And you can do this for all 3 of the points. If it has more points, you can do it for all of them. But once you find 2 of the points, you can just connect it and make the lines because 2 points make up a line. So I've got this, and then it asks you to write the equation, I believe. Write the equation of the line through the midpoints. So you have 2 points. Now you need to write the equation. Well, you need the slope. If it's on a graph, you can count like rise over run. If it's not on a graph, then you're going to need to use the slope formula. Like slope equals y2 minus y1, x2 minus x1. Find the slope and then find the b or y-intercept. In this case, it is 0. So when you go up here, it would look like this point right here, this b. There is the equation, or there's the visual. Y-intercept is 0. It rises 1 and over 1. Rise 1 over 1. That invisible 1 is there. That is the slope. So you're going to try to do this. So what is the reflection rule? Find the midpoints. You really only need to do it twice, but you can do it more. So find the midpoints between C, C prime, D, D prime, etc. And then use those 2 points to write the equation of the line. So midpoint first, and then find the equation of the line. Okay, this reflection. This is a really good video. And actually, if you are a pool player, this could totally help out your game. So watch this, learn about what it is. It uses the line of reflection to actually be a better pool player. I have tried this method. I'm still kind of a bad pool player, but it does help. So watch that. It's like a minute and a half. And then you're going to try to do this. So I need to find the original point. Here's B prime. I need to find B. If this is the mirror, that means point B would be somewhere over here. So we're just working backwards, but you still start with a line that is perpendicular to the line of reflection, perpendicular, and you're going to want to get used to messing with these tools because some of the quiz questions and homework questions, they will have these type of tools on them. So I've got this perpendicular line going through the mirror or the line of reflection, and then I'm going to click a segment. And again, if you find a better way to do this, go ahead. This is the way that I found that works for me. And I want this from this point here to point B prime. That is the radius. So I need a circle. So that's when I grab my compass and it has a circle. So first I'm grabbing the radius, then I drag it to here. That's B prime. That would be point B because it asked me up here to find the original where the student's position is. And then I'm going to check my answer. Hey, there it is, point B. And notice if you watch the video, the pool video, this line lines up perfectly with B prime. And this right here creates an isosceles triangle because these two lengths would be exactly the same. All right. Reflection. Here's overall of the whole lesson. This is what you need to get out of it. A reflection uses a line of reflection or a line of symmetry and reflects over that, or as a mirror image. You have to have an equidistant or equal distance from the line of reflection to each of the corresponding points. So they're going to be equidistant on both sides of the line of reflection, and it's going to be perpendicular. Here's some notation. So reflection across M, line M, of the triangle is triangle ABC prime. The reflection of point A is actually A prime. It didn't move because it's on the line of reflection. And then the perpendicular bisectors that I just talked about. All right, I hope you can do this. Please practice with those manipulating tools. You will definitely need to know those and know how to use them in the near future.